So now let's talk about. Okay, so basically this is being the photocurrent right here on the y-axis, and here we have intensity. So I'm talking about case one. In this case one, light which is emitting on the metal surface having mu, which is less than mu naught. Basically, what I'm trying to convey that the frequency of the light is less than threshold frequency, then we know what is going to happen. Okay, what is going to happen? Basically, the photocurrent will not gonna develop or not gonna generate, and thus whatever may be the intensity, whatever may be the intensity, the photocurrent is not going to generate, and thus the graph is going to be like this. Basically, what we are going to observe that photocurrent is nothing but I is it is going to be zero. I it is going to be zero, whether the intensity is something or not. Okay. So basically, this is the case about which I was talking about, and right now I have case two. Okay. I hope that you have understood about this point. Okay. So basically, now let us talk about when the photocurrent versus intensity curve is plotted against when there is a frequency which is greater than threshold frequency. Okay, so basically in this curve, what we are going to observe that it is going to be like straight line. And as we know about this point. Why? Because the photocurrent is directly proportional to intensity when frequency is greater than threshold frequency, right? Because so many of the photons are going to interact with electrons, so more electrons are going to generate. That's why photocurrent is directly proportional to the intensity I'm talking about right there. Okay, so this is being the graph which I want to talk about. Okay, so basically what I can write here, I can write here that I is nothing but it is equals to KL. Okay, KL where L is the intensity, of course, where L is the intensity. This is being the graph that we are gonna notice right now. Okay, so I am hoping that you are getting the point. So now let's talk about another graph. In this graph, photocurrent versus frequency, what is going to be happen? We know that photocurrent is not going to generate up to up to. Just give me some time. Photocurrent is not going to generate up to a certain frequency, and that frequency is called as threshold frequency, right? Photocurrent is not going to generate. But afterwards, if I'm going to talk about afterwards, what is going to be happen when the threshold frequency is attained? When the threshold frequency is attained, then there would be there would be a sudden increase in current, sudden increase in current. We are going to observe, and I'm drawing with a dotted line. I'm drawing it with dotted line. Okay, um, like let me take some color which is visible to you as well. Okay, this is being the color which is visible. Okay, and afterwards what is going to happen? There would be photocurrent which will gonna generate soon. Okay, photocurrent photocurrent will develop like this after it crosses the barrier of the threshold frequency. Okay, I'm hoping that you're getting my point. What we are going to observe from right here, what we are going to observe from right here, we are going to observe that there would be a sudden increase in the current, and the current is going to be like this. Basically, with this graph, how we are plotting this graph, we know a thing, right? Photocurrent is directly dependent on intensity. Photocurrent is directly dependent on intensity. It is not dependent on directly, directly dependent on intensity. It is not dependent upon frequency. Okay, photocurrent is directly dependent on intensity. That's why I'm saying this. Photocurrent just depends only when the threshold frequency is attained, and afterwards there is the photocurrent which is attained, and whatever may be the frequency afterwards, there would not be any kind of increase in photocurrent value. This is being the graph which I was talking about. Okay, so as you are able to observe, this is one of the thing. Okay, so I'm talking about another graph right now. Okay, this is the graph which is between photocurrent and time. What is going to be happen? Case one, light which is emitting on the metal surface having mu is less than mu naught. Then what is going to be happen? We know that whatever may be the time is passing, and whatever may be the time, the photocurrent is having the value as nothing. Why? Because the frequency is less than threshold frequency. Then whatever may be the time, as the time passes, the photocurrent is not going to be generated. Okay. And this is case two. This is case two about which I am talking right now. In case two, light which is emitting on the metal surface having frequency which is greater than threshold frequency, then what is going to be happen? What is going to be happen? There is a sudden increase. First of all, the current is not going to generate. The first of all, the current is not going to generate in this case, but afterwards, when the when the threshold frequency barrier is crossed, then what is going to be happen? There would be a sudden increase in the photocurrent value like this, and afterwards it is going to be like this because it is not dependent upon the time, it is dependent upon the intensity, and photocurrent is going to generate like this, and this graph will be attained in this graph is going to be attained in just just let me draw, just let me draw. Okay, okay, and again this is being the dotted line. Okay, I'm hoping that it is visible, or if it is not, then I'm changing the color as well. Um, okay, this is being the color that I've choose. Okay, so basically in this time, up to this time, when we are going to observe, just give me a sec. Okay, up to this time, 10 to the power minus 9 second, the photocurrent is going to be generated like this and will develop in the 10 to the power minus 9 second. Okay, I'm hoping that you are getting the point. Okay, so basically, this is the graph that I was talking about. In 10 to the power minus 9 second, the photocurrent is going to be generated like this, and there would be certain increase in photocurrent in the time period of 10 to the power minus 9 second. And afterwards, it is going to be like straight line. It is not going to change with the time. Okay, this was the graph that I was talking about. Now, we have photocurrent versus voltage graph, photocurrent versus voltage graph, and voltage of what? Voltage of collector. Okay, voltage of collector at different intensity. We are going to observe the graph, and of course, frequency is greater than threshold frequency. Okay, uh, we know that at some voltage, basically when velocity is equal to zero, at some voltage, we were able to observe that it was having some value of current, right? Because when I showed you the simulation, in that simulation, you were able to observe that the battery voltage was equal to zero, battery potential was equal to zero, and when the light was emitting from the source and basically emitting on the sorry when the light when the light is emitted on the emitter plate, then there was some electrons which was coming out and making a photocurrent with the getting when they get in the contact of a collector. Okay, so basically when voltage and can be seen as potential was zero, then there was some photocurrent which was present right there. Okay, and what was happened when the voltage of it increases means when the positive side of when the positive terminal of the battery was attached to collector, then what was happened? There was a sudden increase in the current. There was sudden increase in the current, and afterwards it got stable like it was before. Like it was before. Just give me some time. Okay, it got stable afterwards. Okay, but I'm talking about at intensity one. So basically, how why is it happened? Then it increases in some time. It there was a sudden increase in current, and afterwards it got like stable, or can be said as there was no increase in current. Okay, why did it happen? The reason is right here. Graph on the basis of sorry. Basically, I'm trying to explain why that was happened, why saturation current was developed. What is saturation current? Saturation current is nothing but when there was a certain increase in current and it reached to its maximum value. When I'm talking about this point, when there is a sudden increase in current and it reached to its maximum value, then this is called as saturation current. I'm hoping that you are getting my point. Okay, so basically I'm gonna explain about saturation current. What is saturation current? Sorry. Why is it happen? Why is it happen? Because as a gonna make a two cases right here. Just give me some time. I'm gonna make some two cases right here. I'm gonna copying this. Mm, it is not perfect right here. Just give me some time. Okay, here we are having two cases right here. Okay, not basically the two cases, but uh, here we are having two cases in front of us. Uh, in this case, I'm removing these things. Okay, in this case, what I'm going to talk about when it was connected to the plane wire, when it was connected to the plane wire, then what was happening? Then what was happening? Emitter do not contain any kind of a thing. Means it has electrons, but it is not negatively charged because of the battery. Battery is not connected to it, so it is not negatively charged. It is not negatively charged. This is the thing that I am explaining to you right now. Okay, so this is the scenario which we are able to observe. Okay, okay, this is the thing that we are able to observe. And what was happening right here? What was happening right here? Here was happening like when the light was emitted from the source, when the light was emitted from the source, then there was some electrons which comes out from the surface. Okay, there was some electrons which comes out from surface. I'm supposing that it is producing 10 electrons in and then it is producing 10 electrons, and those are 10 electrons are traveling to the collector to the collector in in let's suppose 20 seconds. Okay, in 20 seconds, I'm supposing like this. Okay, this was happening. This is the case one in which I'm talking about. This is totally being an example. I don't know that there are some 10 electrons or basically traveling in 20 seconds. This is the case in which I'm assuming these things. Okay, and what is going to be happen if I'm talking about the current? If I'm talking about the current, the photocurrent is nothing but it is again rate of flow of charges. What was the statement of what was the statement which was given for the current rate of flow of charges with respect to time? With respect to time. This is the statement. According to this statement, what we can do, what we can assume, basically charge per unit time, which is it is flowing, right? So basically the charge is flowing 10 electrons in 20 seconds. This is the value that we are having. Okay. Right now in case 2, what I'm trying to explain, case 2, when emitter is negatively charged and the collector is positively charged, then what is going to be happen? Basically, because there is attached battery with having some voltage V, then emitter got so much negative charge and the collector got so much positive charge as well. Okay, because of the battery, it is transferring its charges to the plate. Then what is going to be happen? If uh, if we have a source which is present right here, and that source is emitting the light on the emitter surface, then there would not be there would not be now basically 10 electrons which is coming out from the surface. I'm assuming here we are having that 100 electrons are coming out from the surface and 100 electrons are coming out from the surface, and those 100 electrons are traveling in same time traveling in same time traveling to the collector in same time. By such same time, because the speed of the 100 electrons are traveling to the collector in 20 seconds. Okay, because the speed of the electron do not changes. Why it not changes? Because it is directly dependent upon the frequency. It is directly dependent and it is directly dependent on the frequency. Why? Frequency is directly proportional to kinetic energy. As we increase the frequency of the source, the kinetic energy of the electrons also increases. That's why I'm saying that speed do not changes, and whatever taking the time to cover this distance will be same for this and for this because the distance is same. Okay, because the distance is same. I'm hoping that you are getting my point. Okay, so right now 100 electrons are traveling to the collector in 20 seconds. Then what is going to be the current now? This is the sudden increase in the current. Why? Because when the battery connected to it, there is a there are some 100 electrons which is uh, here somewhat 10 electrons was getting out, and afterwards 100 electrons are getting out. Okay, so what we are gonna observe? We are gonna observe that The value of this is nothing but 100 electrons upon 20 seconds. As we are able to see that this is the value which is if I am making marking this as I naught, then the new value of the current is 10 times of I naught. Then that's why I'm saying that there is a sudden increase in current. And sir, there is a common doubt. Sir, there is a one doubt. And what's that? Why why afterwards it got basically stable, or can be said as there was no increase in current. It is being the common doubt that we are having. Okay, so I'm gonna so, I'm gonna talk about this. Don't worry, I have copied the slide. So basically, I am removing some content from right here. Okay, okay. So basically, I'm gonna explain right here. I should be removing this diagram as well. Sorry, just give me some time. Okay, okay. So basically, what I'm trying to explain you that when this case was happened, then 100 electrons after some time, we have basically it is the case when it is the case when basically what I'm trying to explain. Let's suppose this was the case which was happening. Then afterwards, this case happened when the battery was connected. Then what is going to be happen after some time? But we are able to observe after some time. But we are able to observe, and this is being very common. This is being very common sense. Why? Because after some times, 100 electrons are gonna come out from the surface. Why not some more or why not less? Because 100 electrons 100 electrons directly dependent upon the battery source, and basically the light intensity is the same. So basically 100 electrons are going to come, and they are going to travel and they are going to travel in just 20 seconds. So basically what is happening after some time, the current is remained same. The current having the same value as of previous one. It is having some value. I'm talking about after some time. After some time, let's suppose this was the case happened at 5 seconds, let's suppose. Okay, and when we attach the battery, it was happened at 6 seconds. Okay, basically it can't be 6 seconds as well. It is in the millisecond which is happening, but I'm writing it as the 6 second. I'm hoping that it is understood. Okay, this the time which is equal to 6 seconds. It may not be 6 seconds. It may be in some 5 point something second, but I don't know what is exact. So I'm assuming like this. Okay, so basically right now Right now, this is after some time. Let's suppose it is after 10 seconds. So the current value do not changes. The current value do not changes after some time. Why? Because 100 electrons are coming in 20 seconds again and again. That's why it is happening. Okay, so if the value of the current do not changes, then what we can say that the photocurrent remain constant. Photocurrent remain constant. Photocurrent remain constant. I'm hoping that you are. I'm hoping that you are getting my point. in this case scenario in this case scenario in this case scenario there was some current. Okay, there was some current. Afterwards there was a sudden increase in the current which is 10 times of the value of previous one, and afterwards we were able to observe the current is being constant because the value of the current do not changes. Okay, that's why we are able to observe this. Okay, I'm hoping that you are getting my point. Afterwards, this is the graph that we are able to observe. Now, but if we change the intensity of the surface, or sorry, but if we change the intensity of the metal, of the light which we are having. Okay, and I have changed the color. Just give me some time. Okay, if mm, okay, so if basically we are going to change the intensity of the light. then what is going to be happen? It is gonna set up like this. Okay, and it is also again going to be parallel to the line I1. It is a different intensity. Why, sir? There is a increase in photocurrent of the intensity I2 because of again intensity is directly proportional to the photocurrent. That's why it is happening. It is and afterwards basically it remained constant as well. Okay, it remained constant as well because intensity is being same for another thing for another light. Okay, so this is the case that I've discussed about. Sir, what is going to be happen when the voltage is going to be negative? It gonna possess the graph like this. It gonna possess the graph like this. Okay, just give me some time. Okay, it gonna possess the graph like this, and this is being the point of stopping potential. This is being the point of stopping potential. Sir, why is it happen? Because we know that as the negative voltage, as the negative potential of the collector arises, then the electrons are gonna stop. Basically, what I'm trying to convey in the basic English, I'm trying to convey when the voltage of collectors switched to negative potential, then what we have observed, the electrons were stopping, right? In the simulation, we have observed. And what was the stopping potential? It was that minimum value of potential by which the most energetic electron also gets stopped. This was the thing that I am talking about. Okay. So right now what we are able to observe as it becomes negative voltage, the photocurrent value decreases. Okay, and after some time it reaches to the null value which is equal to zero. Okay, this is the graph which I am trying to explain. Okay, I'm hoping that you are getting my point. I'm removing these things. Okay, I'm hoping that you got this graph, or if you don't, then you can ask me out again about this graph. Okay, now we are having photocurrent versus voltage of collector graph at same intensity. At same intensity means I'm assuming this is being the metal surface 1 and this is being the metal surface 2. Okay, here we are having just give me some time. Let's suppose this is metal surface 2. Okay, this is metal surface 2. Mm, okay, just give me some time to adjust it. Then okay, now it is being perfect. Okay, so basically what I'm trying to convey, I'm trying to say that there was a light which is incident on this metal surface, and the same light is incident on the metal surface 2 as well, and they are having frequency which is greater than threshold frequency. Then what is going to be happen right there? What is going to be happen right there? Then we are able to observe. Then what we are able to observe at zero voltage. Let me change the color. Okay, at zero voltage, what we are able to observe at zero voltage, the photocurrent is having some value, and afterwards, the photocurrent is increased like this and gonna be stable like this. Just it increases like this, and afterwards gonna be stable like this. Okay, this is for the this is for the uh this is for the basically metal one which I'm talking about. We are having two different surfaces, but the light is being same. Okay, and basically we are plotting a graph of these two metal surfaces when the light is same. Okay, and I'm gonna make it for now yellow metal surface. For yellow metal surface, this is going to be exactly the same thing as well. There is no changing in it. Okay, for the metal surface too, it is also going to be same because the intensity of the light is exactly same. Why? Because the light is being same. Okay, this is going to be happen when it is going to be when the light is going to be incident on the metal surfaces. Okay, this is the graph that we are going to observe. So now, sir, what is going to be happen? Now, sir, what is going to be happen in the negative voltage part? Okay, I am assuming that it may attain some VS1 and another one may have attained VS2. I don't know which one gonna attain which value. That's why I'm plotting like this VS2. Sir, how you determine that VS1 has this value or VS2 and why they are different? First of all, they are different because the material is different properly. That's why they are different. And I don't know what is which metal has the highest value of the stopping potential. That's why I have marked like this. Okay. I'm hoping that you are getting the point. Okay. So now let us talk about another point. What is that another point? Just give me some time. Okay. So now what I'm gonna ask you for this thing. Basically, which one having which metal is having its threshold frequency as higher, or can be said as or can be said as uh, which one having frequency greater. Okay, so if I'm saying that it has frequency V2, okay, it has frequency mu2. Just let me change the color. If it has frequency mu2 and it has having frequency mu1, then which one has the greater value? We know it is having the greater value because the stopping potential is more negative, which is marked right here. Okay, so the the value of frequency would be greater like this. Would be greater like this. Okay, I'm hoping that you are getting the point. I'm hoping that you are getting the point. So if it is like this, if it is like this, then why is it happening? Then why is it happen that stopping potential, which has the stopping potential has higher value, then the frequency value will be higher. Here we are having the simple reason for that part as well also. Why? Because we know that EVS is nothing but it is equal to kinetic energy. It is equal to kinetic energy. And but we know other thing that it is directly proportional. It is directly proportional to just give me some time. It is directly proportional to the it is directly proportional to the frequency as well. Why? Because frequency is directly proportional to the energy. And in energy, there we know that in energy, there we are having two different values, potential energy plus kinetic energy. And if the value of frequency increases, then that means kinetic energy must also increases because energy is increasing. And if that happens, then the stopping potential must increase also. Okay, then it must increase also. That's why I'm saying that the frequency 2 is greater than frequency 1. Uh, and the stopping potential 2 is greater than stopping potential 1. Okay, I'm hoping that you're getting the point. If it is clear to you, then let me know about it. And if there are any kind of a doubt regarding this topic, then you can ask me. Okay, so now I'm going to talk about something stopping potential versus frequency curve. And in this curve, stopping potential versus frequency curve, there are some important things that I'm going to ask to you. Okay, so first of all, let me write something. Let me write some of the things. Stopping potential versus frequency. We know if we want to if we want to make a graph, then energy incident is nothing but it is equals to it is equals to work function. Work function is also denoted by phi. I have explained you and I'm marking this down like phi. Okay, right here also. I have explained you in our previous class that it is also equals to it can be denoted by phi as well. It can be denoted by phi as well. Okay, so this is the thing that we are having. I have changed the color. Now, what is the incident energy that we are having? Uh, incident energy is like h mu. Okay, we are not changing phi because it is being important to us. Now, what is kinetic energy? Kinetic energy can be written like EVS. Okay, so when we are gonna solve this, EVS is nothing but it is equals to h mu minus phi, h mu minus phi. And after solving this, what we are gonna observe h upon e mu minus phi upon e, phi upon e is nothing but it is the equation that we are having for the stopping potential. This is nothing but this is the equation that we are having for the stopping potential. Okay, if it is clear to you, then we can relate with we can make it relate with straight line also mx minus c. Then when we are relating, then when we are able to observe, we are able to observe the m value is corresponding to the h upon e. Okay, and m is also denoted by tan theta, which is also called as slope, which is also called as slope. Okay, so the slope of this curve is nothing but it is equals to h upon e. and the intercept value. After comparing the value of the intercept, then what we are having that it is nothing but it is pi upon e. It is pi upon e, and straight line having equation like y is equal to mx plus c. Then the intercept value must be taken as minus pi upon e. Okay, this is the thing that I want to explain you. Now we have calculated the things which is required to us. Like we have calculated about what is the slope that we are having and what is the intercept value. Then we are able to make the or basically can be called as we are able to plot the curve as well. Okay. So right now I'm plotting a curve. Right now I'm plotting a curve. Just give me some time. Okay. I'm plotting a curve like this. Okay. This is the curve that I've plotted. This is the curve that I've plotted right here. Okay. Sir, we know that it is being straight line. We know a simple point like this that it is going to be straight line. But why you have drawn a dotted line? Why you have drawn a dotted line? This is the homework for you. I want you to answer this thing. I want you to answer this thing. That why I have drawn a dotted line. Why not being the plain line like this? Okay. And as we are having the intercept value like this, then it is pi upon e. We know that what is intercept? Intercept which cross the y-axis. That line or that point of the line, it is called as intercept. Okay. Now it is if it is having angle theta, then what is the slope of it? The slope of it is nothing but it is equals to h upon e. Okay, it is h upon e. In the questions, I'm marking a very important statement right here. In the questions, I'm hoping that it is visible to you. In the question, if value of h is asked, then then don't put or can be called as then solve the value on the basis of on the basis of graph of I'm writing it here on the basis of graph. What sir? What are you trying to convey? I'm trying to convey that we know the value of h is nothing but it is equal to 6.626 into 10 to the power minus 34. But if the question in the question there is a uh, curve between stopping potential and frequency is mentioned, and then you have asked what is the value of h, then you don't have to put this value. You have to calculate uh, by the graph. Okay, basically you need to solve the slope first and afterwards put the electron value and then you may get the value of h. Okay, this is the simple process that you need to do first. Okay, I'm hoping that you are getting my point. Now let's talk about stopping potential versus frequency curve. In this, what we know, the energy incident is nothing but it is equal to pi plus kinetic energy, where pi is work function. We know about it. Okay. And the incident energy, it is nothing but it is equals to h mu, and this is pi plus what is kinetic energy? We are plotting a curve against stopping potential versus frequency. Then EVS. This is being very simple. Okay. So like this. Then what we are having, EVS is nothing but it is equals to h mu minus pi. Okay. Then if Vs is nothing but it is equals to h upon e mu minus pi upon e that we are having. Okay. Okay. This is the value of the stopping potential that we are having right now. Okay. After comparing this with straight line with the equation of straight line, what we are going to observe the slope value of the value of the slope, which is equals to m, which is equals to tan theta. It is nothing but it is equals to h upon e. Okay. H upon e. And what is the oh, okay. Did I do something wrong? Yeah, I have done. No, swapping potential versus. Okay, basically, I'm trying. Sorry. I'm explaining this thing again, which I should not be. Kinetic energy versus frequency. which I want to discuss. It is kinetic energy versus frequency curve. Okay, energy incident is nothing but it is equals to pi plus kinetic energy. We know that. Okay, what is incident energy that we are having? It is h mu pi plus kinetic energy. After solving this, kinetic energy is nothing but it is equals to h mu minus pi. Okay. After solving this, what you are going to observe, it is nothing but y is equals to mx minus c, mx minus c, y is equals to mx plus c. Then after comparing both of them, then what you are going to observe that the value of the slope, m and tan theta, they are equals to h. Okay. And what is the value of intercept that we are having? What is the value of intercept that we are having? It is nothing but it is equals to minus 5. I am hoping that this is the thing which is clear to you, and it is being very basic as well. You know that, right? Okay, this is the thing that we are getting. Again, I'm gonna plot a curve right here. How the curve is plotted. The curve is plotted like this. Again, this is being the dotted line. I want to know answer. Why is it being dotted line each and every time? Uh, in the fourth quadrant. Okay, and it is like this. Okay, this is the point which is of phi. Okay, and this is theta. Then what is the slope right here? We are having it is nothing but equals to h. And again, if the kinetic energy versus frequency curve is mentioned, and you have asked to find the value of Planck constant, then you need to calculate by the value of slope. You do have to put the value of h as the 6.626 into 10 power minus 34. I'm hoping that you are getting my point. Okay, now let's do some question. We have understood each and everything about graph. Okay, now let's do some question. Okay, this is the question which is asked in BITSAT examination in 2023. In a photoelectric experiment, the graph of the photoelectric current versus the intensity L of the incident radiation is. So basically, we know that this is being very simple for you as well. We know that uh, intensity versus sorry, photocurrent versus intensity. This is L. We know that this is the graph which is straight line. So a straight line passing through the origin. Yes, this is being the correct answer. See, the question is being very easy. Now we are having another question, which is also asked in BITSAT examination 2024. Okay, so if you- this is the most frequent graph question students are often asked to identify what is the slope of intercept of the line represents. Okay, question in the graph of stopping potential V naught versus frequency for a metal, the slope of the line is. Okay, this is the question that we have observed, and it is being very easy to us. Okay, in the curve, what is also the slope of the line is nothing but it is h upon e. We have observed right now. Okay, we know that h upon e. We have we have gone through this. Okay, okay. Now we have the question which is asked in JMA's examination. This is the previous year question that we are having in photoelectric effect. Just give me some time. Okay, in photoelectric effect, the sloping potential V naught versus frequency. Okay, this is V naught versus frequency. Curve is plotted, H is the Planck constant, and phi naught is the function of matter. Then V naught versus mu. This is V naught versus mu. Okay, this is V naught versus mu. It is linear. Yes, this is being the correct statement that we are having. Okay, this is the correct statement. Choose the correct answer. We have to mark the correct answer. Okay, the slope of V naught versus mu curve is the phi naught upon h, which is incorrect. Which is incorrect. We know that it is nothing but it is equal to h upon e. So this is incorrect. H constant is related to the slope of V naught versus mu line. This is being correct. We know that after solving the value of slope, we can find the H value as well. Okay. The value of electric charge of electron is not required to determine H using the V naught versus V curve, mu curve. The value of electric charge of electron is not required to determine H using the, yes, this is being correct. We don't have to determine it, or or let or let us go through by another option as well. the work function can be estimated without knowing the value of h. Yes, we can estimate the value of the work function without knowing h. Why? If the curve is mentioned to us between the slope impression and frequency, then we know a thing, right? And what is that? It passes to this point, and if we know that where it is passing, where it is intercepting the point, then we can get the value of work function as well. Okay, so this is being the correct option. This is not being the correct option. By the value of electric charge, let me first of all make it mark it correct. The value of electric charge of electron is not required to determine H using the V naught versus mu curve. Why this is wrong? Because he is saying that if we know the slope of the value, then then to find the value of H, the value of electron is not required to put in this value. Why we are not going to put, when we are not going to put in this thing, then how we are going to get the answer? So this is being totally incorrect. Okay, so I'm hoping that you are getting my point. Okay, this is the question that we have done. Now we are having another question. Okay, just give me some time. um this is a also question which is asked in midset examination of yours 2023. Okay, so that this is the first law of photoelectric emission, which of the following correct? This is being simple. we have uh, we have done this question earlier. Okay, so now let us talk about this question. This is the again bit, it is asked in BITSEC examination 2023. So let's talk about this question as well. The swapping potential V naught versus frequency mu of curve of okay, V naught potential versus frequency curve is plotted to us in front of us. The Planck constant H is again, we don't have to put the value 6.626 like this. This is not being the value that we are gonna put right now. Okay, this is not being the value that we are gonna put right now. First of all, we are gonna solve. First of all, we are gonna solve, and then we are gonna put the answer in it. Okay, so let me solve the value. How we are gonna solve that? We want to know the value of slope. Okay, we want to know the value of slope, and if we get the value of slope, then we can solve the value of Planck constant, right? So what is the value of slope? We are having we are having a slope right here, which is in blue line. Okay, so if it is angle theta, and here we have mentioned that this is the height, which is equals to nothing but it is equals to 16.5. Okay, which kind of value? 16.5. Then what is the value of slope that we are having? It is nothing but 6.5 upon 4. 4. There is no difference in between them. It is 4. Sir, how did you put this? Because we know that slope is nothing but it is equals to tan theta. Okay. Then after solving this h upon e, we are gonna put the value of electron here. Then h is nothing but 6.5 upon 4 into 1.6 into 10 to the power minus 19. Then after solving this, just give me some time. After solving this, let me calculate the value. Just give me the time to calculate. Okay. The answer is nothing but it is 6.60 into 10 to the power minus 34. Like see, here, this is the option which is mentioned for the those people who know the value of Planck constant, and they have just put it down right here. Okay, but the correct answer is option A. I'm hoping that you are getting my point. Okay, this is the homework question for you. This is the homework question for you. Okay, these are being very simple questions. I want answer today. Okay, now we are having another question, and it is based upon de Broglie wavelength, de Broglie hypothesis. So now let us talk about de Broglie hypothesis. As I have told you that I have recorded a session yesterday, but due to some reasons, the audio wasn't recorded in that session, and I basically done so many things in that lecture, and which is right here. Okay, so now let me explain what is de Broglie hypothesis, not wavelength, de Broglie hypothesis. So de Broglie stated that if we have any kind of a matter and can be said as body, and if it is moving with some velocity v, and if it is moving with some velocity v, then de Broglie stated that along with that matter, there is a wave associated with it, which is also moving with some velocity v. And if we need to find out what is the wavelength of the basically wave, then it can be calculated by h upon p. It can be calculated by h upon p. This is the thing that is stated by de Broglie, and it is de Broglie hypothesis, nothing else. Okay, this is being de Broglie hypothesis. nothing else. Okay, where P is nothing but it is momentum, H is nothing but it is Planck constant, and lambda is nothing but it is wavelength. Okay, I'm hoping that you know a relation between. I'm hoping that you know a relation between momentum and kinetic energy. And if you don't, then I have derived it right here. We know that kinetic energy is nothing but it is equals to half mv square. I have multiplied m to the upper side and the lower side as well. And after solving this, uh, I have clubbed them m square into v square upon 2m, and m it can be written as mv square, mv to the whole square, and mv is nothing but it is v momentum. And after solving them, we are gonna find out that it is nothing but it is equals to under 2mp. Okay. On the basis of this thing, on the basis of this thing, there are so many questions that can be clubbed with it and can be asked. Like these are the cases that I'm going to discuss. In that session, I have basically uh, I have done this all things. Okay, but okay, but whatever happened. Okay, so basically, let's suppose it's any kind of a body which is having some mass m, it is moving with some velocity v, which is mass given and velocity given. Then what is the lambda of that body can be asked. Then don't think that how the lambda can be found of any kind of a body, because in accordance of de Broglie, uh, in accordance of de Broglie, as we know, a very important thing which I forgot to state right here. We know a very important thing that Planck stated a very important statement, but but we know about light. Light has a wave nature. We know about it, and Planck stated that light also possesses the particle nature, and with which with which we had the idea of photon. Okay, he also stated that the light is not moving in just the form of a wave; it is also moving in the form of photon, or can be called as particle nature. And De Broglie also stated a very important thing that a matter which is moving, it also possesses the wave nature as well. Basically, here we are having the proper idea of here we are having the proper idea of dual nature of matter, dual nature of matter. Sorry, dual nature of matter. Okay, here we are having proper proper scenario. Okay, so this is the thing that is stated by De Broglie. Okay, how it can be related with, just give me some time. Okay, how it can be related with something like you have mentioned there you have a plate, and there you have another metallic plate like this. Okay, there you are having another metal plate like this, and they are connected to a circuit. They are, just give me some time. They are connected to some circuit like this. Okay, they are connected to some circuit like this, and in between them, sorry, in between them, there is the battery attached to it with having some voltage as B, with having some voltage as B. Okay, with having some voltage as B, and there is a charge which is present on metal plate. Okay, and it because this is being positively charged and this is being negatively charged. Okay, or I should be reversing the polarities of the battery, or let me change it right here. Okay, let's suppose the charge is present right here. Uh, that means it is positively charged and it is negatively charged, right? Then the charge must move in this direction. Let me change the color. Mm, okay, so this is charge Q. Here if we are having positive, here we are having negative. Then this charge must move in this direction. Okay, by if it is moving, then it must have some sort of a kinetic energy, and we know that the kinetic energy is nothing but it is equals to QVS, and it is nothing but it is equals to QVS. Okay, and if it is equals to QVS, if it is equals to QVS, then there are some things that can be asked. There are some QVS. Sorry, first of all, it is not QVS. It is QV just. VS is when it is acting like a stopping potential. Okay, so we know that it is equals to QV. Okay, then how we are going to estimate what is the wavelength of this charge also? There can be asked because the charge is also the part of a matter. It has some mass and then what is the wavelength of this charge if it is asked to you? Then how you are gonna tell how you are gonna determine what is the value of lambda? Then it is being very simple. Lambda is nothing but it is equal to h upon p, and the p can be written as under root 2 n k e. It can be written as under root 2 n k e. And but we know that of course, the voltage of the battery must have mentioned, and the value of the charge must have mentioned also. That then you can solve it. Otherwise, how you're going to determine? Okay. Then we are replacing the value of finding energy like this: Q into V. Q into V. Okay. Now you need to know some values for this lambda. If it is electron, we don't know right now the potential of the battery, but it must have mentioned in the question. Okay. If I'm talking about lambda, so if I'm talking about the electron, and we have asked what is the value of lambda in accordance of this structure, then what is the value of this? What is the value of that? I have mentioned a value right here. Okay, this it is 12.2 upon under root V in Angstrom. In Angstrom. So what is this? This is the value of lambda of an electron when it is traveling like this with having some potential connected to it, which is V. Okay. Then sir, how we are getting the value as 12.2 after solving, after putting each and every kind of a value. Like, just give me some time. Okay, okay. Now it is better. Just give me some time. Okay, so okay, I'm back right now. Okay, so basically this is the value of the lambda of the electron, which we have observed after putting the value of each and every kind of a value, like h, value of mass of the electron, and the charge of the electron, mass of the electron, and the value of h. Then this is the value that you must have noted down. Okay. And if we are talking about let's suppose proton, then this is having the value like 0.286, 0.286 angstrom. Just give me okay. Then it is possessing the value like 0.286 upon under root V angstrom. Okay, this is the value that I am having. This is being the lambda of the proton. If I am talking about alpha, then it is nothing but it is equals to 0.101 upon under root V angstrom. This is the value of lambda that we are having. You can remember all these values. Why they are playing a very important role. Why they are playing a very important role. Okay. Why they are all playing a very important role? Because with these values, with these values, you don't have to put each and every kind of a value like h and mass of the electron and charge of the electron, then solve it. It is already being pre-calculated, and you can just put the value of voltage of the battery, then get your answer in angstrom. Okay, and in questions generally, the lambda is asked in the form of angstrom. That's why it is mentioned, nothing else. Okay, it can be related with collision as well. If I'm assuming that you have some idea of collision. If you don't, then let me know about it. I'm gonna explain you about collision as well in the another sessions that we are having in future. Okay, so this is the case of before collision, and this is the case of after collision. Before collision, I am assuming that we have a body with having mass m1 and another body with having mass m2, and it is moving with some initial velocity u1, and it is moving with initial velocity u2. Then after collision, when we have observed, of course, it may not have the value as previous value. It has some value v1 and it has some value v2. Then if we want to find out what is the if we want to find out what is going to be the lambda for the mass m1, then we can have the after collision. Of course, this is the case after collision. Then it can be written as h upon m1 v1, h upon m1 v1. And so from where we are going to calculate what is the value of V1, we know the formula like this. V1 is nothing but this equals to M1 minus E M2 into U1 plus 1 plus E into M2 U2 upon M1 plus M2. Okay, if we put this value, then we can estimate the value of lambda of the mass M1 It can be asked also. I'm not so sure that it is going to become or not. If it is asked, then you should not be blanking yourself. You should not go to blank. You should be solving it. Okay. And if you want to find out for the mass M2, then replace wherever the number 1 is present, replace by 2. Okay. Like here we are having 1, replace by 2. Here we are having 2, replace by 1. Like you can do like this. Okay. I'm hoping that you are getting my point. And on the basis of that, I'm explaining some questions to you. Okay. Uh, This is the question that I'm going to discuss right now. This is also, it is asked this question. Just give me some time. Where is my marker? Okay. I have chosen a white color, that's why it's not visible. Okay. Right now, this is also asked in your examination, BITSET examination 2023. An electron of mass m, an electron of mass m and charge e, initially at rest gets accelerated by a constant field 2e. Okay, I am assuming that E naught has value which is equals to 2e. I have assumed that for our easy calculation purpose, the rate of change of d Broglie wavelength. But we have asked to us the rate of change of d Broglie wavelength of this electron at time t, ignoring relativistic effects. Is relativistic effects basically uh, some of the things that changes when it is accelerated like that. So basically, so, in this question, we have to ignore those effects, which is on charge, may be able to observe, be observed. Okay, so I'm copying this slide. Okay, I'm gonna solve it right here. Uh, of the question beside examination. Okay, so this is the answer. So what we have mentioned here, we are having a electric field which is equal to 2e, and I have mentioned that it has value like E naught. I have equated it with E naught. E naught is the general variable or general value. Okay, so basically like this, and here we are having a electron with us. Here we are having a electron with us, and this electron is present in the electric field. That we know something about. We know about this, right? What kind of a things that we know? Of course, when it is in electric field, then it will move anti-parallel to, it will move anti-parallel to, anti-parallel to, parallel to electric field. This is the thing that we know. Okay. And if this is gonna move anti-parallel to electric field, then if it is moving in accordance of laws of motion, in accordance of laws of motion, uh, first law, basically the law of inertia, it states that if something, basically a body cannot change its state. A body cannot a, a body cannot change its state if there is no force applied on it. If there is no force applied on it, this is the first law of inertia, which is given by Newton. Okay, means anybody can't change its state if there is no force applied on it, and if the change, if we are able to observe, if we are able to observe the change in state, then what is happening? It may have some force. Then what is the force it is having? We know that if electric field is applied, then it has force value which is equals to E into E. E into E. Okay, this is the most basic thing that we know. And if you don't, then let me know about it. Okay, and we also know a formula, mass into acceleration. If I'm gonna relate it with it, then we are having the value of acceleration as E upon m. Sir, why you have calculated the value of acceleration? Because there is something asked to us, and what is that? We have asked that it is what is the value of d lambda upon dt, rate of change of wavelength with respect to time. What is this? This is the thing that we have asked. Okay. So to find out that what is the lambda that we know, it is nothing but it is equals to h upon mb. H upon mb. Okay. So I'm putting in this equation. I'm putting in this equation. Then the differentiation of h upon mb is nothing but upon dt. H upon m. is the constant part. So basically it gonna comes out from the differentiation, and we are gonna differentiate this. Okay, we are gonna differentiate with this. Okay, after differentiating this, I'm mentioning right here h upon m, and the differentiation of 1 upon v. Then what we are having, it can be written as it can be written as it can be written like uh it can be written like v minus 1, and after differentiating this, what we are having, minus 1 minus 1. I'm getting some noise pollution. Just give me some time. Okay, so right now it is better. Okay, then it comes out from the differentiation. And after differentiating this, what we are going to observe that it is equals to b minus 2, and the differentiation of velocity is also going to be done. Why? Because this is being the chain rule that we know. Okay, if you don't know the chain rule, then let me know about it as well. I'm gonna explain you about the chain rule as well. Okay, so this is going to be like this, minus 1. Okay, just minus h upon m v square, and it is nothing but it is written like acceleration that we are having. Okay, this is the final value that we are having of dl upon dt, d lambda upon dt. Okay, but this is not mentioned in the terms of acceleration or velocity either. So what we have to solve? We have to solve it further to get the full and final value. Okay, d lambda upon dt is nothing but it is equals to minus h upon n v square and v square into acceleration. Now, sir, what is the acceleration? Before putting the acceleration, I want to know what is the final velocity which it attains. Why it attains the final velocity? Because it is first of all present at rest in the first case scenario, and if it is accelerating with a if it is accelerating, then it may attain some final velocity as well. Okay, and that final velocity is dependent upon time directly. Okay, then what is that final velocity? We are gonna put a kinematics equation. Okay, we are gonna solve it by kinematics equation. What is but what is kinematics equation? It is nothing but v final is nothing but it is equals to u plus at. Okay, what is initial velocity? It is equals to 0. Okay, at, then we are gonna put it like this. After putting after substituting this value, but value v is equals to 80. After substituting this value, okay, a t to the whole square acceleration minus h upon m into a square t square into a. Okay, a2, this got cancelled out, minus h upon m a t square. Okay, this is the full and final value that we are having, but it is in the terms of acceleration, and the question which we have asked to do, it is not in the terms of acceleration, it is in the terms of electric field. Okay, so what is the acceleration value that we are having? If here we are having electric field as value like this, e naught, e naught. Okay, because the electric field is nothing but it is e naught. Then what is going to be acceleration? For this acceleration is nothing but it is equals to 2e e upon m. This is being simple. Okay, this is the value of acceleration that we are having. Now let me put it right here. Okay, I'm putting it right here. Then the d lambda upon dt is nothing but it is equals to minus h upon m. The value of acceleration is nothing but it is equals to 2e upon m. And here we are having 2 t square. M to m got cancelled out. Minus h upon 2e e t square. This is full and final value that we are having of rate of change of lambda. I'm hoping that you are getting my point. I hope you have watched this session until this time. And here we are having this is being our correct option. Okay. Thank you for watching the session till the end. And complete your homework on the basis of that. This is also the homework that I'm giving to you right now. Okay. I'm This is also being the homework question that I'm giving you. Homework question. Okay. I want the answer of all of them, which I'm mentioning right now. Okay. Here we are having another question. It is also homework for you. If you can do, then do this question. Otherwise, if there is a no, if there is a time constraint, then we'll solve in the question. We'll solve in the class. Okay. Thank you for the watching the session. Hope you understood. Hope you understood.